Propulsion system of the future. During more than 40 years of space flight, a lot of things have changed. Today's space shuttle is a luxury ship compared to the Mercury capsule that carried the first American astronaut into space. 40 years ago, a lot of people might have had a hard time believing that Americans and Russians would be living together in space on one space station. Space probes have visited every planet except Pluto, and a mission there is currently being planned. One thing that has changed very little, however, is the way rockets work. While different fuels have been used, and current rockets' engines are more high-tech than their early predecessors, the basic concepts involved are basically the same, but NASA researchers are currently working on a way to change that as well. What should a future spacecraft engine be able to do? Certainly one major goal would be for it to allow spacecraft to travel through the solar system more quickly than it can now. While a lot of things have changed in over 40 years, today's spacecraft are still traveling at the same speed that John Glenn did when he became the first American to orbit the Earth in 1962. One possible way to change that would be the Variable Specific Impulse Magnetoplasma rocket, VASMA. Not only would VASMA allow for faster space travel, it would have some pretty incredible side benefits as well. For example, NASA researchers believe that VASMA would be able to travel to Mars much more quickly than a contemporary chemical-powered rocket, and then once there, to refuel on Mars for the return flight to Earth. The VASMA engine could also even help protect astronauts from the dangerous effects of radiation during the trip. In the less distant future, VASMA could even help keep the International Space Station ISS in orbit without requiring extra fuel to be brought up from Earth. VASMA is a plasma-based propulsion system. An electric power source is used to ionize fuel into plasma. Electric fields heat and accelerate plasma, while the magnetic fields direct the plasma in the proper direction as it is ejected from the engine, creating thrust for the spacecraft. The engine can even vary the amount of thrust generated, allowing it to increase or decrease its acceleration. It even features an afterburner mode that sacrifices fuel efficiency for additional speed. Possible fuels for the VASMA engine could include hydrogen, helium, and deuterium. The use of hydrogen as the fuel for the VASMA project has many side benefits. According to researcher Franklin Chandais, in addition to being the director of the Advanced Space Propulsion Laboratory, Chandais is an astronaut who flew into space on 7 missions, more than any other NASA astronaut. We are likely to find hydrogen pretty much anywhere we go in the solar system, he said. What this means is that a VASMA-powered spacecraft could be launched with only enough fuel to get to its destination, such as Mars, and then pick up more hydrogen upon arrival to serve as fuel for the return trip home. Another benefit of hydrogen fuel is that hydrogen is the best known radiation shield, so the fuel for the VASMA engine could also be used to protect the crew from harmful effects of radiation exposure during the flight. Electrical power sources for the VASMA engine could include such things as a nuclear power system or solar panels. For long-range flights, Shanghai said that the best option is nuclear power. Nuclear power is definitely a must if we are going to go to Mars, he said. This means that VASMA could be integrated with NASA's recently announced Project Prometheus proposal to develop nuclear power generators for the space flight. While solar power would not be practical for flying farther out into the solar system, it could have applications closer to home. After VASMA completes some additional Earthbound testing, its designer hopes for it to be tested in orbit on board the International Space Station. A prototype engine would be mounted on the ISS just to demonstrate how it works. The prototype will draw its electrical power from the station's solar panels. If the test was successful, the VASMA prototype could be moved to a different part of the station and used to help keep it on orbit. While ISS orbit the Earth, atmospheric drag gradually pulls it closer to the Earth. Every so often, the station has to be boosted back into the higher orbit.